Okay. So see, yesterday we have done a NAT configurations or a NAT lab, you can say. So in the NAT labs, we have configured like source NAT with exit interface, source NAT with IP pool, a pool of IP addresses, right? Then we have configured destination NAT as well. In the destination NAT, we have done a NAT with any, which means any port would be allowed or any port would be NATed with our private IP address. Then we have done a NAT with a specific port address translation or a DNAT with a specific port number. Then only specific port would be allowed, right? So any questions in this, guys? Okay. If no questions, we'll move forward. So today we will be going with SSL inspection. So first we will go with SSL inspection theory. Then we will go with the labs and what is SSL inspection we will understand. Okay. So to understand SSL inspection, let us understand how does the traffic flows in our environment, or whenever you connect to any of the website, what happens. Okay. So the full form is SSL means secure socket layer. Transport layer security. The outcome of both is the same, to provide a security when the traffic is flowing via internet. Okay. So now generally what happens, suppose this is your client and you are having a server. Okay. And you are connected to internet, and this is also connected to internet. So now from a client you want to have a website access or whatever application hosted on the server you wanted to access. So what you will do, you will initiate a communication and server will respond. In between there would be a TCP three-way handshake will happen usually. Okay. So now this connection is going via internet, right? Whatever we are initiating from a client to a server, this is going via internet, right? Which means open internet. Now suppose this connection is not secure or it is in a plain text environment. Okay. And you are sending something, your bank data. Suppose this particular server is a bank server. Now you are sending something over a bank, over a public internet, your password or your pin, whatever you are sending over a public internet. Then any bad attacker or someone is sitting on the internet is trying to do sniff your traffic, okay, or do a packet capture of your traffic. So he would be knowing what is the username, what is the password of your bank website or whatever website you are going, right? Why this is happening? As of now the traffic is not encrypted in our environment. Assume there is no encryption happening, so the traffic is going via plain text, and anyone can read this or anyone can know your what you are doing in your when you are communicating with a specific server, what data you are sharing with each other, right? If it is a plain text. Now we don't want a plain text, we want a security. So to overcome with this, or to overcome with the internet communication when the traffic is going via internet, we have a security, we call it a SSL security or a TLS, transport level security. Okay. So now what will happen, whatever server is sending a data, server will encrypt this, and then the data would be sent to our client, will encrypt and data would be sent to server. Then server can decrypt this. In between, if anyone did the packet capture also, they will not be able to read it because data is encrypted. Encrypted data can be read by only server, and server, whatever server is encrypting, again server will send this data and only client can decrypt this. Okay. So in between client and server we want a secure communication. Okay. So suppose if you don't have this proper SSL TLS communication, your data would be going in a HTTP, which means it is not secure at all. Then if you want a secure connection, the data should be going with HTTPS. Okay. That means your connection is secure. Whatever you are sending, that would only be read by your server, and whatever server is sending, that can only be read or decrypted by your client only. No other person in the middle can decrypt or encrypt the data or even they do a packet capture, they cannot read this. Okay, is it clear?
Yeah, yeah, but what is the difference in like why they are not using three-way handshake instead of this? Why they are using
No, no, no. Three-way
SSL
handshake.
TLS?
See, HTTP also three-way handshake will happen. HTTPS also three-way handshake will happen. I'm saying three-way handshake will automatically happen. Doesn't three-way handshake doesn't give any security. Okay. Three-way handshake means I am sending a SYNAC to check
Mm.
if you are alive. Then server will send SYN plus acknowledgement that I am alive, and you can initiate a communication. And client will send a acknowledgement. Okay, let us start a communication. In this, there is no security at all. A three-way handshake will happen by default, whether it is HTTP traffic or it is HTTPS traffic.
To
Okay,
establish the connection, it will happen.
correct. If it is a TCP traffic, anyway,
Okay.
three-way handshake will happen. Okay. Apart from three-way handshake, what security we are having? See, suppose three-way handshake, anyhow, it is happening with HTTP and HTTPS both. But if you are using HTTP without SSL TLS protocol, your data is going in a plain text, right? If someone is doing a packet capture, they can read whatever data you are sharing with. Now, with HTTPS, our data is secure. If someone is doing a packet capture also, they will not be able to read what is there inside our data. Okay. So now, how does it happen? Let us understand now. You understood how what is TLS and SSL, right? The
Yeah.
overall or high level purpose. Now assume, now this is my client. 1 minute. Okay. Okay. Now this is our server. Three-way handshake is normal, so I am not discussing about three-way handshake. Okay. Now a client wants to communicate with the server. Client will say, I want to communicate with you, and this is my cryptographic algorithm, or I am using a so and so cryptographic method. Okay. He will send whatever cryptographic method he is using, SSL TLS 1.1 or 1.2, whatever it is. Okay. Assume TLS 1.2 he is using. So he will say, I am using TLS 1.2 protocol to communicate with you. Then server will say, okay, I am using same protocol, but I am having a server certificate also to do encryption and decryption of a packet. Okay. With the certificate, I am having a CA certificate also. I am having my own certificate, and I am having the certificate signed by a specific CA, which means certificate authority. Now this particular traffic went to our client. Now what client will do? Client will check, do I have this particular CA in my trusted host or trusted authorities? If this particular CA is added into my trusted authorities, I will accept this server and I will initiate a communication. I will say accepted. Then server and client both will create one session key. Using this session key, the actual data, now the data sharing will start. So the data would be encrypted using this particular server key, session key, and the same session key would be used to decrypt the data. So you can think this session key as a password between the client and the server. Okay. So first server and client will authenticate each other using the certificate. Okay. Server will say I am using so and so certificate with the CA authority. Can you authenticate myself? And if you have the CA server in your trusted authorities, you can authenticate me. If not, you will not be able to authenticate me. So client will say, okay, I have the CA server in my authority list. I accept you as a server, and we can initiate a session key. We can create a one new session key. So using the session key, the client will encrypt the data. The server will decrypt the data. Okay. And same thing, a server will encrypt the data when sending, and the client will decrypt this data. Okay. So usually with the help of a certificate, both the server and client will create the session key, and with the help of session key, the actual data encryption and decryption will happen. Okay. Is it clear? Hello?
Yes.
Okay.
Yeah, clear. Yeah, clear.
So now let us go. So what is SSL TLS? Let us see theory again.
One
SSL.
second.
Hmm.
Sorry to interrupt. In some firewall policy, we are using no SSL inspection, right? In that case, how the security will be
I'll
achieved?
come to that point. Where we use SSL inspection, let us discuss in couple of minutes, okay? First, let us
Okay.
understand how SSL works and why do we need it.
Okay.
Okay? So,
Okay.
SSL TLS. Secure Circular and TLS transport level security are cryptographic protocol designed to encrypt data between a client and a server. Ensure privacy and integrity of a communication. Whatever I am sending, nobody else is reading this, and it is only read or it is only modified by a server only. Okay, authenticating the server. So usually we are what we are trying to do. We are trying to authenticate the server with the CS certificate. Okay, if server has a CS certificate, we will authenticate. If not, we will not be able to authenticate the server. Okay. So why is TLS needed? When you browse a website, suppose you are browsing any website, if it is HTTP without SSL, data is in a clear text. If it is anything password, credit card information or anything, anyone can sniff and anyone can see what you are sharing data, right? So we need data is encrypted. So with the HTTPS with SSL TLS, data is encrypted. Only client and server can read this. Nobody else can read this particular data. Okay, that is clear. Now let
Yes.
us see how does SSL TLS works. Client initiates a communication. Hello, I want a secure connection. Send supports the protocol versions and cipher suite, which means whatever TLS version I am using, I will send. Then server to a client. Hello, here is my certificate, and certificate contains a public key and a signed CA. So a server will be certificate would be having the certificate CA authority from where the certificate is signed. Okay. Then step 2, verification. Client verifies certificate is valid, issued by trusted CA, doing a match certificate, domain match certificate. Then step 3, exchange key. Client and server agrees on a session key for a encryption. There would be a session key created between client and the server, used to encrypt all the further communication. Which means actual data, whatever it would be shared between client and server, that would be encrypted using this particular session key. Secure communication. All HTTP data is now encrypted with HTTPS. Okay. So now let us see one more slide. 1 minute. How TLS SSL works. The request, your browser attempts to connect to a website and ask it to identify itself. The identity check. The server sends a copy of SSL certificate which includes its public key. Along with public key, it would be having a CA authority also. Validation. Your browser checks the certificate against a list of trusted authorities. If it is valid, the browser generates a pre-master secret, a temporary key, encrypts it using the server public key and sends it back, creating the secret code, which means a session key. Using the session key, both the sites then used to create a session key. Secure session is started. For the rest of that, all data is scrambled or you can say encrypted using the session key, making it unreadable for anyone. Only server and client can read this particular data. Okay. Now how can we see what is encrypted, what is decrypted, or how does a certificate can be seen? Let us see. If I go to google.com, okay. Now you can see there is no error of HTTP error or anything. So if I click here, connection is secure, right? Let us go here, certificate is valid. So you see this is a common certificate. There are multiple things in this particular certificate. This is SSL certificate, okay, and issued by means issued by whom? This is a CA certificate issued by Google Trusted Server Services, or you can say Google Trusted Services issued this particular certificate, and this is a SSL certificate. Now if I go to any other certificate, let us not check Google now, let us check another thing. If I go to anydisk.com, this is another website which is also having HTTPS, right? So now let us see this particular thing also. Connection is secure, certificate is valid. This is also anydisk.com. This is also issued by Google Trusted Services, right? Now if I check another thing, cisco.com, connection is secure, certificate is valid. This is issued by some different vendor. It is not issued by Google. Okay, this is IdenTrust. There are many certificate providers available. It can be a GoDaddy, it can be DigiCert, it can be Google services, it can be Microsoft services, it can be IdenTrust. Any provider can give a certificate. Okay, so this is called a global certificates or public certificates provider. So now how does it works? Assume you are going to any website. You want to go to any website or you want a certificate for a website. First you need to have a CSR. CSR in a certificate means certificate request. Okay, then the CSR would be signed by a CSR server. So signed CSR is generally called SSL certificate. Okay, and the signed CSR is signed by some CA, right? That is CS server, right? That is called a CS certificate, or you can say global CS certificate, whatever you want to say. Generally it is called a CS certificate. What is used to sign this particular CSR? So normally in our environment, how does it work? Let us see now. Just give me 1 minute. Okay, so this CSR,
Maybe who will be installing this certificate in like endpoint? Are those like
I'll come to that.
the
So now I'll come to that. Give me 1 minute. So the CSR, suppose you have a website. Generally the CSR would be generated from your like web server, or you can do it from a open SSL application also. Okay, generally done by your server team or a web server team. CSR will be signed by CS server. This would be done by your CS server team. Then signed CSR is generally called a certificate and the CS server. So the CSR will be signed by CS server, right? This signed CSR you need to install in your web server again. As of now I am not coming to SSL inspection. We are just seeing how the browser works or how the internet works, right? We'll discuss how does inspection works and all later. So this web server installation again done by your server team or your web application team. Okay, then a CS certificate. If it is a global certificate, you don't need to install it. Already Windows will be having a global certificates available in their directory. If you see, if you go to our, let us see, settings, security, manage certificates, view imported certificates. So these are the global certificates, Microsoft root CA. There are so many certificates. Frontier BS, that is mine. If I click here, any search is there. Let us see. I will search it with the certificate like Google or DigiCert. DigiCert is one certificate available. Then there would be so many certificates available in our browser itself. We don't need to, if it is a global certificate or a paid certificate, we don't need to use it. Okay, we don't need to import it or install it in any of the client environment. It would be already available. Okay, now comes the inspection part or the problem we would be having. Okay, okay, now all the traffic is encrypted, right? Now assume this is your client. connected to a firewall. There would be L3 switches and all in the between. I am not discussing about that. Then a firewall would be connecting to your internet service provider. Okay, then you would be having a Google here. Then you may be having a FB Facebook here. You may be having any disk, whatever internet websites, you would be having all these websites. Okay, now a client is going to google.com. This is one connection, encrypted, end-to-end encryption we call it. Okay, whatever is encrypted here only decrypted by the Google, right? Because a client is using Google certificate for encryption and decryption, and same thing Google is using, right? A common CS certificate they are using, and common session key. A client and a server created a session key to encrypt and decrypt the data, right? Same thing will happen for any disk or Facebook also. It would be encrypted here, it would be decrypted there. Okay, now in between we are having firewall, right? But firewall cannot read actual data. Firewall can, at the moment, a firewall can only allow or deny traffic based on layer 3 or layer 4, which means based on IP address or based on TCP and UDP port numbers. Okay, now assume we are going to any other website, and website is having some virus in this. Okay, a virus usually loaded into L7 or actual payload of the our packet, right? The virus will not come into L3 or L4 layer, it will come to your L7 layer, right? So now firewall cannot read L7 application or data payload anything, because it is encrypted between a server and a client. Firewall cannot do anything in this environment, right? So now if any virus came to our user, he is going to any website and he downloaded some virus, how firewall would be able to secure? Firewall will not be able to secure this particular traffic, because he cannot read the payload of the packet. He can only read L3 and L4 traffic, right? Is it clear?
That's why we are using next. Yeah, okay. But
Yeah,
that's why we are using next gen firewall, right?
yeah, we'll come to
To
that point. Yeah,
monitor the layer 7.
we'll come to that point. Yeah. So now with specific SSL TLS, the traffic is only encrypted between client and a server, and the client is using a server certificate to create a session key. Correct? Now we need a solution. We need a firewall to read all the L7 traffic. Okay. So to overcome this solution, we have this problem. We have a solution. We call it SSL decryption. Okay. So in SSL decryption, what will happen now? This is your client again. Internet service provider. Now we are having Google, Facebook. Okay. Now with the SSL inspection, a client will not create a direct communication with the Google. Okay. Between previously without SSL decryption, what was having? There was only one session. The session was between client and the server, right? Now with the SSL decryption, there would be one session between the client and the firewall, and there would be another session between the firewall and your Google server. Second session. So now on the firewall we would be having our own certificate. Okay. So whenever client wants to communicate with anyone, firewall will say, this is my certificate, authenticate myself. Client will say, okay, authenticated. Now we will create a new session key. So now only encryption and decryption happening at a firewall to client level. Then firewall will again encrypt this and send the encrypted data to a Google server. So this is a second encryption and decryption happening. So what will happen? A client send the data, firewall will decrypt this, read entire payload, then again encrypt this data and send it to your server or Google server. Okay, then a Google send a return traffic. Firewall will decrypt this, again read the traffic, and again encrypt and send it to your client. Okay, now here for a client, whenever client is going to any of the website, he will not be knowing that what is a Google certificate and all. We will be installing our own certificate on the firewall. Okay, so for a Google, now usually if you don't have encryption decryption, you are going to any website. Okay, what certificate you are getting? If you are going to Cisco, what certificate you are able to see? You are able to see cisco.com, right? And issued by whatever. Now when we are doing SSL decryption, client will see your internal certificate, your internal SSL certificate issued by your own CS certificate. So on CS server, you would be having one internal CS server. That particular SSL certificate will be signed by your company CS server. Okay. So between a client and firewall, this particular certificate would be used for encryption and decryption of data. Okay, and between firewall and the Google, still the public certificate or Google certificate would be used for encryption and decryption. Now for a Google, the client is firewall, and for a client, the firewall is a server. So firewall is acting a two. Firewall is doing two parts now. For a client, it is acting as a server. Okay, and for the Google server, it is acting as a client. Okay, so client thinks, okay, I am connecting with the firewall, and firewall is my Google server, and firewall will initiate another communication on behalf of client to a Google server. Okay, saying I want to communicate with you, I want so and so data. Then Google server will send the data to firewall now. Is it clear?
Yes.
Okay. So now let us go again to our theory. So SSL decryption, SSL inspection. So in FortiGate also we have two type of inspections. One is certificate based inspection and one is full inspection. So now let us understand this also, because this would come to your real time environment. There are two type of inspection in FortiGate. So what is certificate based inspection? When you select a certificate based inspection, firewall only reads a data till SNI field. Whenever you have any certificate, you would be having a SNI, which is called server name identifier. Okay, so if you go to any website, this is the right common name. This is a SNI field, or not only common name, you would be having subject alternate names. Where it is subject alternate names. You are saying this all DNS names, right? This is called a SNI fields in our certificate. So with SNI field, a firewall can only read a server name identifiers. It will not be actually reading a data. With the full inspection, a firewall will decrypt and encrypt, which means it will read full data. Okay, at what level we need a certificate based inspection and what level full inspection, we'll discuss that in couple of minutes. Okay, so in FortiGate we have two type of inspection. One is certificate based inspection, which will not decrypt anything. The firewall only looks at the envelope of the message, specifically the SNI, server name identifier, in the SSL handshake. Okay, so at what level we will use this particular SSL certificate? When we are doing a web filtering or when we are doing a URL filtering, we can use a certificate based inspection, because usually a URL name or web application name or FQDN name would be available in your SNI field or your SAN field of a certificate. Okay, which is subject or subject name or subject alternate name. So by seeing this particular fields, you can able to recognize what is a website, that particular website you are going to. Okay, when you want to do only allowing or denying of your websites, then you can use a certificate inspection. Now we have a different requirement that not only a website allow deny, we want to do an antivirus scanning, we want to do intrusion prevention, DLP, anything we wanted to do, application control we wanted to do. All these things are available actually in a data, right? If any virus is coming, that would be coming in your payload. You wanted to do intrusion prevention, you wanted to check a complete packet of your environment, right? Passing through a firewall. In that case, firewall need to read whole data. For that, you need to do SSL full inspection or deep inspection, you call it. Okay, is it clear?
Yes.
Okay, so now if we wanted to do SSL inspection in FortiGate firewall, how does it work? Let us see. Till now, whenever the client was connecting, it was using a server certificate or Google certificate assume. Now a client will connect to a FortiGate firewall, right? So you need one SSL certificate. The requirement for SSL decryption, you need one SSL certificate signed by CS server and a CS certificate also you would need. This cannot be done in our lab environment, but I'll show you how to do it. So first thing, in a FortiGate firewall, you need to generate one CSR, which is called certificate signing request. Okay. After generated the CSR, you need to give this particular certificate to your CS server. A CS server will sign this CSR and give you back the SSL cert plus CA root certificate. When you are doing SSL full inspection, this CA root certificate should be installed in all the clients, or you can say endpoint machines. That can be done from your SCCM machine. If you are using any Intune push, this can be installed in all your client PCs. Okay. Then this SSL certificate, whatever we have imported in our firewall, that need to be called into a SSL profile. Okay. Is it clear? Let me show you a
Yeah,
step
clear.
how to do this. So now let us go to our lab environment. We will come here. Let's close all these things. Okay. Let us go to firewall now. Now, if I go to system and certificate, I will say create new, generate a CSR. In the CSR, I can give a name, certificate name, suppose SSL cert. Then what is the IP of a certificate or domain? I can give a firewall IP. Then organization unit, organization suppose lab, location Hyderabad, state Telangana. Then email is optional, SAN field is optional. Okay. As of now, my firewall does supports low encryption, so I can do 512 bits only. Using this particular crypto bits, the actual sessions would be encrypted and decrypted. Okay. So I will say click on OK for now. I have created one certificate, right? CSR certificate. So if I download this, I would be having a CSR. You see SSL cert CSR. That means certificate signing request. This CSR I need to give it to my CS server team. They will sign this CSR and give you SSL certificate, signed certificate. Once you get the signed certificate and root CA, first you need to install the root CA server. So you see a CS certificate. Just click on CS certificate and click on file. They will give you a CS certificate file. You need to upload the file and click on OK. Once you import the CS certificate, then you need to install the CS, your signed SSL certificate. So for that, click on this particular and click on certificate. Now you will be having option to import the certificate. Just import the particular local certificate and click on upload. Whatever certificate you are having, a signed SSL certificate, that you need to select and click on OK or create new. Your certificate would be installed in this particular firewall. As of now, certificate is just imported in the firewall. It is not called anywhere or anything. Now you need to use this certificate for your SSL decryption. So for that, we need to create SSL profile. So for that, you see SSL SSH inspection. I can create a new profile. I will say here you see inspection mode, certificate based inspection or full inspection. If you select a full inspection, there would be error coming. The SSL profile used for full inspection, end user will likely see certificate warning unless the certificate installed in their browser. So that means the whatever, if you are using full inspection, the certificate is signed by one CA, right, or one CA server. So you need to install that CA root certificate in all the endpoints, or else your endpoint or end clients will see a certificate error in their environment. Okay.
Okay.
Then
Okay.
whatever certificate you had, like SSL certificate, that would be showing here once you create. Okay. So that would be there once that is created. Suppose I created, suppose, test SSL. This particular profile I can call into, okay, maximum number of entries. In our firewall we cannot use it because of license issue. So this particular test SSL or whatever profile you are created, you can call it into your security policies. Okay. Once you enable any security profiles, we'll come to that point in couple of minutes. Here you see SSL inspection. You created one profile that would be showing here, and that you can use it for your security profiles, antivirus, web filtering, DNS filtering and all. Okay. Is it clear?
Yeah.
Where we will get that certificate which we install on the endpoint.
That would be 1 minute. See, when you are when you generated a CSR and you gave the CSR to your CS server team, right? They will give you SSL cert and a CA root certificate also. This is a root certificate which you need to install in your endpoint clients. Okay. And that can be done by your CS server team or your server team who is managing your SCCM. There would be automatic pushing of a data or applications to endpoints, right? Using SCCM or Intune, they can do it using that. That would be there in your CA. You would be having one CA, one server which would be acting as a certificate authority. In that you would be having a root certificate that would be used for signing all the clients. Okay. So any questions? Okay. So now at what profile we will use what? Let us see. So now SSL decryption communication between client and server with SSL we see. Now at what security profile we use what? We will come to deeply in all the security profiles. We are having web filter. We are having DNS filter. We are having then application control, antivirus, IPS IDS signatures, IPS signatures. Okay. So using a web filter. Web filter is generally used to block a websites, right? So can be done by certificate inspection. DNS filter, DNS query, it can be used by certificate inspection. Then rest all. If you want application control cannot be identified the data with the certificate inspection. You need a full inspection. Then antivirus, again you need a full inspection. Then IPS signature, again you need a full inspection, because apart from web filter and DNS filter, all the traffic or all the data would be there in your L7, which needs firewall need to check what is happening and what is not happening in your environment. Then you need a full inspection in this particular environment. Okay. Is it clear?
But we always
So your
inspection
voice is breaking.
instead of we can use full inspection all the time instead of using certificate
Yeah,
inspection,
yeah, we can use
so
doesn't
that
there is
all
no
the
such
security
limitation.
policies.
Yeah, yeah, yeah. You can use a full inspection for all such profiles as well. But if you use certificate inspection for application control or antivirus, you will see that the traffic is not getting blocked, even it is a virus or you blocked some application, it is not getting blocked at some moment with the certificate inspection. But if you use a full inspection, doesn't matter. Websites will also get blocked. There is no such limitations with full inspection. Okay, is it clear? Hello.
Yeah, clear.
Okay. So any questions? Let me know, guys. Or else we'll wind up for today because we need to start another chapter with security profiles. It will take a longer time. Let me know if you guys have any questions.